folks. So I work for Elastic, the makers of Elasticsearch, Logstash, Kibana, and Beats, and a number of other projects that are used for monitoring. I'm a community engineer there, which means I go around and give workshops and talks. I sometimes do this for free at companies if you want to know more about our stuff, or if you're planning on using the Elk stack. So today's going to be like a fairly full talk. There's a lot of thoughts I have on web monitoring. It's not going to be very practical, so we're going to take a step back, and I'm going to try to think and to take you through my thoughts of how we arrived at where we are today with web monitoring, and what are some interesting things that vendors, that companies are doing right now, and how we might be able to influence the future of where all of this goes. So let's get started without further ado. So we'll go briefly through history, present, and the future. So I am assuming everybody's familiar with this kind of view. So that's a log from one application on one server. And this is how I started my career, just tailing logs and cutting them. Then at some point, you add a web. You break it up into web application server, into a data store, into a web proxy like Nginx or Apache, but it's still reasonably possible to keep tabs on these. You start learning when something's broken in the middle of the night, where you might need to SSH first. And that's your method of troubleshooting. Then at some point, it becomes a little bit more complicated. Now you have to scale. You have multiple application servers, multiple data stores, multiple Apache or Nginx proxies, and probably other components by this point. So that's the point where it becomes quite challenging. And that's where we started like federating or collecting data together. And this happened many years ago, probably 20-25 years at least. There are venerable old projects like Isinga, for example, and Nagios, who we all, maybe not all, but who many of us may have used or have come across, to essentially collect together logs and metrics. So, speaking of logs and metrics, the way that I see the monitoring space is we arrive at each next step in monitoring by having an unovercomable problem. So initially you don't know what's going on in your app at all, and you just need to see something. And the default debugging method for an app is text. That's how we debug our applications when we are developing them on our own machines. And so we transfer this to servers, and so you have a problem, and then you have a solution that rises to meet that problem, and that's logs. But then it's not always clear why these errors are appearing. So you start wondering, well, how much resource is this using? It doesn't behave the same way as on my machine. And to be honest, my machine is probably very different to what's out there in the cloud or wherever else we're running the app. And so we start collecting metrics, start federating things like CPU, like RAM, disk I/O, network, and so on and so forth. This is an example of a modern solution for that. So that's in Kibana, one of the Elasticstack apps. That's a view of a Kubernetes cluster nowadays. This is specifically the CPU per pod. And you can have RAM, network, and other things. You can also view the hosts, for example, or individual containers, if that's how you roll. So we had another problem, right? Okay, we don't know what's going on in the environment itself. Maybe our app is being reaped by the out-of-memory killer, or just the thing is sluggish and we don't know why, and the logs are full of errors, but they don't correlate with the actual problem, which is say that we ran out of CPU or we're pushing some other boundary. Okay, so that we have a problem and we try to solve it with metrics. Well, these are black box metrics. So far we're on the outside. We are looking at a black box that's producing some output for that's the most polite word I can come up with. And so I got logs and metrics. Then further on, we came up with other things. Now there are many vendors for these kinds of systems. If you haven't seen them before, that's an APM system. That's application performance monitoring. There, for example, New Relic, Datadog, and it's a whole host of vendors. Elastic also has one now. So, who hasn't used an APM system actually, or who doesn't have one deployed? Raise your hand. Okay, cool. So I highly recommend that you do look at one, because this is what changed my life for the better the most. So I've used all of the things so far that I showed you. I've like SSH and just looked at logs. I've SCP'd logs or rsynced logs from different machines to my own, and then grepped them all together. And I've used parallel tooling to do the same thing. But the truth is that this pretty much made sure that I didn't have, or this kind of thing, it was New Relic that I used, not Elastic back in the day, but this kind of thing made sure that I had to look at logs and metrics a lot less often. The reason for that is because this is kind of like an X-ray directly into the code of your app. So here you see a feature that these are different colors, just maybe not that visible on this slide, but this is distributed tracing. So for example, here you see exactly how long each transaction takes. You can see what queries it's issuing. So if the problem is like a very slow query, rather than having to go, oh, well, CPU on a server, and then you have to trace, maybe look at the slow log that you have enabled, if you have enabled it, or maybe you enable it and then you wait, and it's a lot fiddlier to come in from the outside. Whereas this would allow you to see a problem like a slow running query very quickly. And there's not visible here actually, but all of these will have things like collective bar charts where the transactions are grouped. So for example, this is a typical fast transaction. You can see microseconds on here, but you'll be able to select transactions that take, like traces for transactions that take like 10, 20 seconds on the other side. So you'll be able to see the trace, a typical trace for that. So, and here the different colors represent different services. That's what I was going to say. So that's distributed. That's the distributed tracing part. You can. Sorry. Yeah.
What do you mean with services? What kind of services?
Different services.
Okay.
So for example, sure, yeah. So for example, the top layer here is React. That's where the request is first encountered by the system, and so the React part, the Node.js part, and the Java part are all instrumented with an Elastic APM client, an agent, which is like a middleware, and it sends information to an APM server, which is then sent to Elasticsearch, and then you can look at it. Sorry?
Acronym.
The what?
APM, what acronym?
Application Performance Monitoring. Yes. So you can, that's useful for any microservice architectures or any kind of service-oriented architectures where you have a boundary. Yeah, so you go front end and back ends, and it can go across them. So this is a really useful way of monitoring your systems. Like I've done other talks that focus solely on APM with demos, and I highly recommend that you install something. I don't particularly care which vendor you use. Like this one is free, so you can try it.
Which one is, what is the name?
This is Elastic APM.
The Elastic APM.
Yeah. Right. I work for Elastic, so I'm showing you some of the tooling. Is that? But I will show you other vendors, interesting things from other vendors as well in this talk, actually. Speaking of which, I should get on, because 20 minutes is difficult. So, story of monitoring for me is the story of like frustration and discomfort. I remember being woken up in the middle of the night mostly and having to fix things very quickly and being under pressure to fix them. Otherwise, I would feel that I failed as a professional. Even when actually sometimes the way that the system was set up and the decisions of other people about what tooling we could use affected how quickly I could diagnose a problem. But it was, there have been some of the most frustrating moments of my career and contributed greatly to burnout that I had about 2 years ago. So I'm quite keen on improving the status quo there. So at the moment, this is what I hear and what I see in this type of space. So there is monitoring, and this is pretty much, I would say that Elastic and a few similar vendors are in the monitoring space. So there's logging, metrics, and tracing, which are the three things I showed you, and possibly also security, which we'll stop on for very shortly in a second. But there is also kind of a peer to monitoring, which is the concept of observability. We'll stop at that too. This is an example of a security thing. Elastic has recently gotten into buying security companies. I think we are on our third one now that we've acquired. So the idea here is that, okay, well, you collect all the logs and all of these metrics. A lot of this information is the same thing that a SIEM system would use, like a security information events system that the security analyst would use to protect you. So we might as well use the same information, like from the logs and the metrics, plus additional info to actually build a security system and to build a security perimeter. So I'd say that I'm just showing it to you as a recent addition. This is probably not something, if you're in a small company, it may not be something that you do yourself, but you maybe have a vendor, or maybe you don't have anyone at all that cares about this. At which point, this is why it's useful for you to know that a thing like that exists. This thing is also free, but to be honest, it's of relatively little use without security experience. So anyway, it's an interesting trend though, adding security to logs, metrics, and tracing. We'll see where it goes. Now, where we are at the moment in this space is, I find that this is a great illustration. 51 useful tools for log management, monitoring, analytics, and more. And I looked through the list, and I knew about half of the tooling, and they are all they're legit projects, right? There's open source stuff, like Prometheus and Grafana. There are vendors. There's the Elastic projects are all there. There's SaaS vendors. There's like New Relic and Honeycomb and many others at Splunk. But how do you make a decision in that environment about what to use, right? I mean, that's too much. Because everybody's trying to make money off this space, including Elastic. So for a second, though, if we go back to observability, I highly recommend, who hasn't read this webpage? You would have remembered if you had. Interesting. Take a picture. So I'm gonna break a rule of presenting and actually read off my speaker notes for a second, because this is the opinion of a competitor who I really respect. This is the CEO of Honeycomb, Charity Majors. So observability is the power to ask new questions of your system without having to ship new code or gather new data in order to ask these new questions. That's an interesting, quite vague definition, but it is an interesting, different one. So then she gives a difference between monitoring and observability according to her. Monitoring is about known unknowns and actionable alerts. So you have to set your own thresholds, right? And you have to know what you're monitoring for. Okay, so monitoring is about known unknowns and actionable alerts. Observability is about unknown unknowns and empowering you to ask arbitrary new questions and explore where the cookie crumbs take you. Observability means you can understand how your systems are working on the inside just by asking questions from the outside. Okay, that probably doesn't, it may not click very immediately for you since it's somewhat of an abstract concept, but you can kind of see the point, right? With monitoring, you kind of know what might go wrong, and so you try to protect against that, and you try to build a system that tells you when it goes wrong. Whereas with observability, the idea is that you can, for example, do a much richer retrospective. And according to Charity, this requires kind of a different sort of system, a different type of tool entirely, like high cardinality, being able to go back to each individual monitoring record rather than sampling your data. There are a lot of things that go into it. If you haven't heard of it, this is it's a good concept to discover, and I think this post is a good place to start. Also, a lot of vendors use the term observability when they are doing monitoring, logs, metrics, and tracing. So that's something else to be aware of. Okay, so I'm going to talk a little bit about interesting things that are happening right now that go beyond logs, metrics, and tracing. Because so far I've kind of rehashed stuff and introduced you to a little bit of new stuff, but not enough, I think. This is Lightspeed. Somewhat similar. I'm not an expert on neither Honeycomb nor Lightspeed, but somewhat similar perhaps to the Honeycomb IO software as a service. And also a competitor to Elastic, at least you might say in the APM space, kind of, sort of. But it's actually kind of a different way of thinking about troubleshooting your systems as a super category. So the interesting thing here, anyway, is you got a latency histogram, like this sort of thing you would get from similar tooling as well. The interesting thing is this chart. You would get a service diagram from many other services, including New Relic, and Splunk, yeah, but many others. Elastic as well, you saw one actually. Right, so, but this red circle here are errors. Errors here. Errors specifically related to the transactions that you're looking at. And it's kind of difficult to quite understand that you have to click around the interface. They have a demo, by the way, so you can play around on the Lightspeed demo. It's like no sign up, just go and click. They take you through a scenario. So anyway, this thing, the idea here is that it shows you the origin of the errors, that the group of errors that you're looking at. So there's like an error in the iOS mobile app. Okay, we detect this, fine, right? Okay. And then there's like an API gateway that's passing along the error, fine. But then actually the error we can trace back to this store server service. And the idea is that this tool is supposed to do this for you, like to show you the origin of an error, the deepest layer of an error. And I think that's quite interesting, and it's also quite well animated, so you feel like you're playing Command and Conquer or something. All of these move, it's very fancy. So that's an interesting feature, this kind of mapping and error tracing and mapping it onto the visual map. Another interesting feature is Honeycomb. Are two features that are produced by Honeycomb. So talk a little bit about more their overall view in a second. But the interesting features here are that you get like my history, what you have looked at, like literally what graphs you've looked at, what CPU or RAM or tracing you've looked at and when. Also an interesting piece of information, like during the night. Even more interesting is what your teammates have looked at. Now that's a curious feature, right? So here you see that Bob has looked at these specific graphs and when. When you have an incident at 3 a.m. and then the next morning at, say, 11, you come in and you do a retrospective with the team, you can use this information, like this collaborative information, to try to build a much better picture. And also, even if that doesn't happen, even if it's not something that you use in a retrospective, you could evolve this kind of feature to train more junior people from more senior people, like so for seniors to train juniors, because then the seniors will always do their best, hopefully, to train their junior colleagues, but it's always possible to forget what you were doing. It's always possible to forget a step. Like, what did you look at to obtain information? Not what remedial steps you took. What did you look at? It's like who copy pastes each URL they look at when they're diagnosing a problem. So that's great. I imagine this might in the future, but if somebody else takes it as an idea or Honeycomb does it, might evolve into some kind of playbook or workbook that you actually construct. We do these now anyway, disaster recovery playbooks, and you construct it or part of it directly in your tool, in your monitoring tool. So that would be quite an interesting feature. Okay. Right, another interesting thing is, so this is by Elastic again. This is unsupervised machine learning applied to monitoring. It's an anomaly detection thing. So there are some interesting things here. For example, top influencers. So these are, it collects, you already need to have instrumented your app to collect metrics and the tracing with the application performance monitoring stuff that I showed you with the individual breakdown of transactions. But once you have that, you could use machine learning. This is paid, by the way. Everything else I showed you from Elastic was free until now. This bit is paid. So, but I'm showing it to you because I'm kind of talking about the evolution of where things might go. Eventually, I'm sure it will be free, just like the other stuff. So here, this user.name and transaction.name, these are attributes of the problematic transactions that the system has decided influence latency. Like I didn't tell it to put user.name here. It analyzed all of the data that it's getting, completely unsupervised and unlabeled, and it decided that a specific user using the system was causing more of a problem, and that like update owner transaction was the biggest, also caused the biggest problem. Okay. Right. So I think this is quite interesting. This is a shot of the unsupervised learning model. These are the model bounds, and here some anomalies it has detected. Here is stuff like typical, because it learns the typical behavior of your system with about 2 weeks worth of data. So it's like typical is 38 milliseconds, and now impact more than 100 times lower. And then you can click through to the APM analysis. So other differences. I started a couple minutes late, but I know that I'm coming up on time. So I'm almost done. Another difference between the various vendors is the way that they charge you. So there's some people charge you per node or per application, per instance of the application deployed, some of the data volume, data storage, or compute. This is kind of what Elastic does, if you use Elastic Cloud at least. Otherwise, for the commercial stuff, there's expensive licensing. Some people charge you per ops user. Like so, Lightspeed, for example, has this kind of thing where they have pricing per team and then per user. So there's a lot of variety for you, and different vendors will fit like a different niche in the market. So Elastic with this freemium model, if you're like a small company, you can start with it. Or if you're a non-profit, start that, they use that. But then if you pit like, for example, Elastic versus Splunk, like Splunk is sometimes some people think it's more expensive, but it depends very much on the use case. What will come out more expensive? You have to try it. Now the other difference, besides business models, and I would like to see more innovation in the business model space towards making things cheaper, but that's not what companies want. So the innovation there is difficult, and only comes through new entrants, new competition. But more interesting is the entire strategic view. So Elastic and Splunk do logs, metrics, and tracing. Like Splunk just acquired a company to do tracing and is now complete in that sense. Elastic has done it for a while. And like their idea is that they're a one-stop shop. Like you give us all of the data you put into this stack, and then you don't have to go elsewhere, and you don't have to transfer data, and you don't have to glue together many different services, which is fair. Like that is a pain in the neck. It's very valid. So for Honeycomb has totally different ideas. Again, I won't be able to present them well enough, but they're worth reading about. So they think about events rather than log lines. They talk about structured information rather than logs and metrics separately. So they kind of mush them together in order to produce a diagnosable system. Unknown unknowns that we spoke about. And what does the system teach you? So when you log into your monitoring system, what does it tell you that's new? And so there are a few other frames, but these are the two main ones that I am aware of, and also that I would have time to speak about. But it's an interesting, in monitoring, it's kind of the entire way of thinking that's different. Like you approach it from totally different angles, and that results in different tooling as well. You can't necessarily compare it like apples to apples. Of course, you could always compare pricing, but you'll get different uses out of them. Right, so I need to finish up this very end of it. So the idea that I have here is trying to make you all think, oh, how can we influence this? You could talk to your vendors. Actually, that really does help. I guess it depends on the vendor, but if you talk to Elastic, my colleagues and I will listen, and like the feedback is passed on, and we do wonder what to do next. Like, we're not wizards. So product managers really kind of decide where the space goes. But really, I think what has worked really well, and it's certainly what worked for Honeycomb as they were entering the market, and it's what worked for some senior ops people who had an impact on what vendors developed, was just go give talks at conferences and then rant at us, at the vendors, in the talk. I go, like, talk about your frustrations. Actually, just focus on the frustration. Just explore it, explain it, like tell us how you feel, right? In a talk. That tends to capture the attention like really strongly. We have a list of over 500 employees at Elastic called sightings, and I and my colleagues and many people at Elastic send things like that to that list. And I'm sure the other vendors have similar approaches and Slack channels and so on. So yeah, go rant at us. Thank you very much.